Evening, students. Here we are again. Time to make you. Oh, I'm not on yet. That's because I have to be ready before I go on. Okay, how do I move this thing? Can you? I guess you can. All right. Talk out loud and see if it goes. Hello, students. I'm ready to make my next recording for you. I'm going to talk about the things that we cover in class on day 3 regarding the metric system and unit conversions. The intent is to get better at understanding how to use the metric units and how to convert between one and another, and also how you represent large and small numbers, meaning you're going to use metric prefixes and scientific notation, most of which many of you will remember scientific notation, but perhaps you haven't used it for a while, so you're needing some practice. So when we're using these things, it's going to be pertaining to physical quantities, things like mass, volume, temperature, density, and some other physical quantities, things that have both a number and a unit. And these things are going to be things that you can measure. Physical quantities are things that we can measure. And the units that go with them, they're going to be standard units of measurement, hopefully things in the metric system, preferably they are. I try to stay away from things in the English units because they tend to be very awkward. It's not our emphasis in this course. So we're going to look at what kinds of units go with these things and how you get from one unit to another in doing problem solving. From Chem Activity 4 that we did on Tuesday, you should recall some of these specific things and remember them and put them on your note card if you need to. So just get familiar or put them on your note card. You will use these things many times as the semester goes by, especially in this chapter. So what you need to remember how to do is know that a centimeter is 0.01 meter, or 100 centimeters equals 1 meter. Both of those state the same equality. Many students will prefer the second one. The second one you need to know here, or the second unit, is the milligram. In other words, I'm talking about prefixes here. That first one was actually centi. It doesn't have to be meters. It could be grams. It could be seconds. It could be liters. The second prefix is milli, and 1 milli anything is 0.001 of that thing. And so you can equivalently state it as 1,000 milli something equals 1 of something. In the case of grams, it would be 1,000 milligrams is 1 gram. Most folks like to use it in the second fashion without the 0.001 version. The next prefix that we came across that you need to get good with is micro, and here in this case it's used with liters. So micro means 10 to the minus 6. You can equivalently state that as 10 to the minus 10 to the 6th. Speak carefully. Microliters is 1 liter, and you need to be able to use these all carefully, correctly in doing problem solving. I'll show you some examples as I go. The fourth one here then is the kilogram, or kilo prefix. Kilo means 10 to the third, which is also 1,000. So 1 kilo of anything is 1,000 of that. In this case, a kilogram is 1,000 grams. When we're working unit conversion problems, and there's a lot of them in this chapter, and you'll see many more of these in various forms as the semester progresses, you'll need to follow some specific steps. First, you're going to set up a unit plan. Determine what the first unit is that you have, what units you need to use to get to a final answer in another unit. And each arrow will be a conversion factor. So each arrow requires an equivalency between units, something like these centi, milli, micro, and kilo prefix type units shown at the top of this slide. So find these ratios and then put them together in such a fashion that as long as you set them up so that the units are going to cancel almost all the time, you're knowing that you're in the right place when the units cancel. Very reassuring, to put it simply. All right, let's do some more discussion here. So for mass, we're going to look at grams. For length, we're going to look at meters. For volume, we're going to look at liters. And for temperature, typically Celsius, sometimes Kelvin. You're going to use both of them. We'll get back to them a little bit on another day. And seconds are the same regardless of which units we're looking at. SI units, metric units, they kind of feel similar. I don't care if you know which ones are which. It's not important to us. But you should be able to use either of them. The English equivalents are not anything anyone's going to memorize. I will always provide those to you if you would need them. The prefixes that you need to know that come from your textbook are in Table 1.6, and you'll need to recognize, hopefully, that these are very much the same as the ones that were shown in your POGIL activity, Activity 4, and the ones that I want you to make sure that you pay attention to are primarily the ones in blue, except for nano is normally on this list, deci normally is, and mega normally is. Nano doesn't end up in our usages often, so the ones that have a check mark here are ones you should know. Recognize what these symbols mean in terms of multipliers. So kilo means 1,000 of something, or 10 to the third of something. So a kilogram is 10 to the third grams. Or pick another one. Milli means 0.001 of something, and so, or 10 to the minus 3, which is 1,000 either way. A milligram is therefore 0.001 grams. Get good at these, refer to them as needed, put them on your note card if that helps. Okay, so let's do some problems that require some conversions and uses of exponent, scientific notation, and metric conversions. So if we're going to try to convert this value of the speed of light given in centimeters per second to meters per second, we'll need to decide how to set this up. The unit plan would be as follows. So, go back. So the unit plan would mean that we start with centimeters per second. Then we have to go from there to meters per second. The seconds won't need to be converted, but the meters and centimeters are going to be our conversion. So the conversion factor we need here relates centimeters, well, let's not put the equals yet, relates centimeters to meters. And hopefully some of you will remember that 100 centimeters equals 1 meter. The other way you can state that is 1 centimeter is also exactly the same thing as 0.01 meter, 1/100th of a meter. Oh boy, that's difficult to write. I'm not quite used to my tool here. Sorry about that, folks. Okay, setting up the problem now that we have a unit plan, and then conversion factors. Only need one of these, or equivalents are going to be used to make conversion factors. Use these as ratios, and you'll see how you want them to set up so that the units cancel. All right, so let's get started with the value provided. So you always take the given value that you have, in this case 2.98 times 10 to the 10th, doesn't like to write very quickly, sorry, centimeters per second. Then we're going to set it up to have a conversion factor goal here so that we end up with not centimeters anymore but meters. So we'll need to put the centimeters on the bottom and the meters on the top, and we'll pick whichever the ones we choose from the step 2 up here that show the equivalence. I'll put in the one that most folks tend to like, and that is 1 meter is 100 centimeters. If you do that, the centimeters will cancel, and the units that remain are the ones that you want. So your initial value, the 2.98, now only has a different exponent after it. Instead of 10 to the 10th, well, 10 to the 10th divided by 100 is 2 powers of 10, and so that would be 10 squared under there. So 10 to the 10th, I'm going to write it out for you, divided by 10 squared, And when you have exponents in the division, you need to subtract. Therefore, the answer becomes 2.98 times, well, what do you get when you take 10 minus 2? I bet it's 10 minus 10 to the 8th now. And be careful as you always write these out to include your units at the very end. 10 to the 8th is the exponent here of meters per second. All right, that was one problem. Not so complicated. Let's try another one. In this case, we're looking at the diameter of the cell. The diameter of the cell is rather small, but we're going to go from meters to micrometers. So the unit plan is going to take us from meters to micrometers. We'll need a conversion factor to do that. So conversion factors, well, let's see. How many meters and micrometers go together? If you go back a couple of pages in your thoughts and or the slides in this presentation, you will recall that 1 meter, let's do it the other way, micrometer is how many meters? It's 10 to the minus 6 meters, but not everyone likes that fashion, so we can write it the other way. Both of these are equally correct. 10 to the 6th micrometers equals 1 meter. All right, now, in order to proceed with this question, we'll then set it up using the given value, conversion factors, and then things such that they cancel out. The first problem, however, is that this value is stated in a fashion that's a little bit awkward. Using these all those zeros there is not always handy, so it's easier to state that in powers of 10. In this case, it's 2.0, and we have the 1, 2, 3, 4, 5th place after the decimal, so that would be 2 times 10 to the, you tell me, minus 5. So we'll use that as our starting value instead of the zeros. It's a little simpler to use things in scientific notation, you will find. You may go the other direction and punch them into your calculator as you please, but if you don't have to, sometimes doing it without the calculator is a little less likely to have errors. All right, 2 times 10 to the minus 5 meters, 2.0 times 10 to the minus 5 meters. That 0 is important. We'll talk about that more the next time. And then now we're going to set this up so we get it to micrometers. So 10 to the 6th micrometers. That's a very odd looking micro symbol. I'm sorry, my tool is not cooperating as cleanly as I wish. Divided by equals 1 meter. They're equivalent. Now, the meters will cancel. That's the goal. The answer becomes a value in micrometers. It's still going to be 2.0 times, well, what power of 10? If you're having multiplication with powers of 10, well, then you add the exponents. So in this case, you have minus 5 plus 6. So the answer is 10 to the 1. And so 2 times 10 to the 1 meter is also exactly the same thing as, oh, but perhaps we're doing this incorrectly. What have we forgotten? The answer there looks like 20. Oh, because I wrote the wrong unit. It's 20. It's 20 micrometers. I canceled out the meters. Always check your work to make sure it looks like it makes sense. If you've written the wrong unit, that will throw you off for sure. So micrometers makes a big difference. It's not 20 meters. You know how big a meter is. It's bigger than a yard. But 20 micrometers is a lot more credible for the size of a cell. All right, let's do another one. So this time we're looking at the diameter of a lead atom. It's already given in powers of 10 in scientific notation. And we're going to go from meters to nanometers. So the unit plan, this time we're going to go from meters to nanometers. You'll have to look that one up if you don't remember it. And when you do, you'll find that you can get a conversion factor using the equivalence that 1 nanometer equals 10 to the minus 9 meters. 10 to the minus 9 is what nano means. All right, set up the problem, and we'll use the value given, 1.46 times 10 to the minus 14 meters. Thankfully, in scientific notation, we wouldn't want to do this without powers of 10 because it would be very clumsy with lots of zeros. Now we'll set this up so that the meters are on the bottom where they'll cancel. And on the top, we'll put nanometers. So 1 nanometer is 10 to the minus 9 meters, exactly the way it's stated in that equivalence. And again, the meters are going to cancel. The answer this time is nanometers. The last one was a different unit than this. And when you have powers of 10 in your problem and you're dividing, you will subtract the exponents. So you'll have 1.46 still times 10 to the, well, what's minus 14 minus 9? That's fine. So minus 14 plus 9 becomes minus 5. Answer is 10 to the minus 5 nanometers. All right, that's how that problem is done. Hopefully that makes some sense to you. So that's as much as I need to give you for today. We will look at things about significant digits and such next time.